Hey guys, this is just a brief review on lesson 11.2. I know that Mr. Carnes did some videos on this stuff, Mr. Kleinhens did. If you guys are interested, here is how I teach it. It might just help you to hear it from me because you know me, or I might say something a little bit different than what they said. In section 11.2, and you're going to have a quiz on this, not this week, but next week, there are some things, and Mr. Carnes talked about this in his video. It starts to get confusing because we're talking about segments, and then we also do some things to talk about angles. And so I'm going to start by talking about segments. And my first picture is, you can see a circle, and it has two tangents. Remember, a tangent just touches the circle. And these two tangents to the same circle meet outside the circle. And when I think about this in terms of these lengths, okay, and really, and again, Mr. Carnes said this, you don't have to even worry about that extra part. So if you think about it like a party hat or an ice cream cone, if you think about a good hat or a good ice cream cone, these two sides better be the same. If these two lengths are different, your hat's going to be all off, your ice cream cone is going to melt in a funny way. Okay, so anytime you see these things meeting on the outside, it just means that those two parts are equal in length. Okay, so if this is 25, then this is 25. Okay, now, Mr. Carnes also talked about this formula that's outside times whole equals outside times whole. And there are three different ways that could look. And one of them we just talked about. And these two are a little bit different. So if I look at this picture, and again, I'm talking about two lines, any two lines that meet outside the circle, this is the relationship between the segments. So when I look outside, so I'm only going to look at this top red part. The outside the circle part is A. The whole thing, I have to add those things together. Sometimes students forget and they multiply, they do A times B. You don't want to do that. It's A plus B. If this is 5 and this is 10, the whole thing is 15. It's not 50. So in this case, I do A times A plus B is equal to the outside, okay, of this other black secant, okay, that's just C, and then the whole thing, I have to add C plus D together. Okay, so that goes with this one. The second one, those two lines are still meeting outside the circle. I have a tangent, I have a secant. And maybe they continue, but I don't really care about the parts that continue after we go through the circle. So again, the outside part, I'm just going to look here, the outside part of the green is E, and the whole thing, I would add E plus F together, is equal to the outside of the black, that's G, times the whole thing. Well, the whole thing is still just G, so I can do G times G, or of course I could write that as G squared. Okay, so that's something to think about as you're doing segment formulas. Okay, segment formulas. This last one, we just talked about it as being either a party hat or an ice cream cone, so we know H is equal to I. Okay, if you still want to use outside times whole equals outside times whole, it's the same thing. Up here, what part is outside the circle? H. What's the whole thing? H. Okay. What is outside the circle in the black? I. What's the whole thing? I. H squared equals I squared. If you take the square root of both sides, you just end up with this anyway. Okay. So that's kind of a complicated way to do it, but if you just want to focus on one formula for all segments, when they meet outside the circle, this is the one you should focus on. Okay. When segments meet inside the circle, and of course now we know that these are called chords, if they continued on like this and this, they'd be called secants, okay? But that's not the point. The idea here is, and the way that I taught it to you guys, was to create two similar triangles, okay? Vertical angles. Those two angles are eating the same arc. That means they are two similar triangles, and all you have to do is set up a proportion within the triangle. So J divided by K equals L divided by M. So the proportion works only if those lines cross inside the circle. Okay, now Mr. Carnes talked about it. This is the hard part. We're not just talking about segments in this section of the book, we're also talking about angles. So when I talk about angles in circles, I always think of it like inside, outside, or on. And when I use these three words, I'm specifically talking about where do those lines meet. Do the lines meet inside the circle? Do the lines meet outside the circle? Or do the lines meet on the circle? Now this one we already know. This is just an inscribed angle. So if I'm looking for this angle, remember that's what we're talking about for all of these. If I'm looking for an angle, all I have to do is figure out whatever is getting eaten, okay, and cut that in half. So I'm going to call this 2x, okay? Whatever this arc is, the inscribed angle when they meet on the circle is just half. So I'm going to say when it's an angle that's on the circle, I'm going to take the arc, and there's only one arc. This mouth is only eating one arc. It's like I could totally ignore the rest of the circle. It's only eating one. So I'm just taking that arc and I'm dividing it by 2. Okay? Now, when they cross on the inside, so I'm going to put my x here. Okay? Now remember, these are vertical angles. So this is also the same thing. These two things have to be the same. I don't know what this arc is. I'm just going to call it A. And I don't know what this arc is, so I'm just going to call it B. So when the two lines cross on the inside of the circle, then I have to find the average of the arcs to give me the angle. Okay? So in other words, arc A plus arc B, add them together, then divide by 2, and I'm out of space. I have to put B a little closer, is going to be equal to angle X. Okay? So I'm just going to add these two up, divide by 2, and that's going to be equal to this x and that x both. Okay, so we're just finding the average when the two lines meet on the inside. Finally, when the two lines meet on the outside, our formula is going to look really close to this, but the difference is instead of adding, we're going to be subtracting. So again, the angle x, angle x, angle x. Now these are 3 different examples, but notice the lines are meeting on the outside in all 3. Okay? And I'm going to use C and D, C and D, C and D. Now notice I made C the big arc on every single one. D is going to be the small arc. Remember, if we're talking about an angle for this course, it has to be a positive number. Later on in math, you're going to learn about negative angles. We're not doing that this year at all. Okay? So if I want to find the outside angle, all I have to do is take the big arc minus the small arc, then divide by 2, and that gives me the angle x. Okay? So in my case, I've used C and D every time. It would be C minus D divided by 2 equals x. So again, when you're thinking about angles, you're thinking about inside, outside, or on. If it's on the circle, there aren't 2 arcs, so all you're doing is taking the one arc and dividing by 2. When they cross on the inside, there are definitely 2 arcs. It's kind of like a 2-headed shark. Okay, it's so hungry it's got to eat 2 things. You're going to add them up, then divide by 2, and that equals this x and that x. So if I add those x's, it also equals a plus b. Okay, and if it's on the outside, this thing's so hungry it's one mouth eating 2 arcs. So in this case, you take the big arc minus the small arc, big minus small, big minus small, and then divide by 2, and that gives you your angle. Okay, so hopefully this helps you a little bit. I also want to talk about your Google quiz from 11-3. These results weren't that great, so I want to make sure that we're talking about it and you understand how to do all of these. Number 1, okay, if we look, it's talking about an angle. X is an angle. So for angles, I'm thinking inside, outside, or on. Where do these 2 angles meet? I'm sorry, these 2 lines meet? They meet outside the circle. So outside means big arc minus small arc divided by 2. So x, that's the angle that's outside the circle, equals the big arc, 125, minus the small arc, 27, divided by 2. Okay? Sometimes students, when they do this, they just throw it into their calculator all at once. So they just do 125 minus 27 divided by 2. but then your calculator only divides the 27 by 2. So make sure you're subtracting first and then divided by 2. So your answer for number 1 should be 49 degrees. Now, number 2 is the same thing in terms of we're talking about angles, and they do cross on the outside of the circle. Okay, but this time they don't tell us what this arc is. We have to find that arc. So for number 2, I'm still using the same formula. Which angle is outside? Well, that's 50 degrees. Okay, what's my big arc? That's 170 degrees minus x is my small arc, and divide by 2. So a couple different ways we can solve this. Some of you guys are going to put a 1 under the 50 and cross multiply, and some of you guys are going to just multiply both sides by 2. That's probably what I'm going to do. Multiply both sides by 2. Okay, so 170 minus what gives me 100? Well, that's 70 degrees. Okay, or we can of course subtract the 170 on both sides. Negative 70 equals negative x, so positive 70 equals positive x. Okay, next for number 3, again we're talking about angles. Okay, and these lines cross on the inside of the circle. So when I'm doing an inside angle, okay, so inside angle, I take the big arc plus the small arc and then divide by 2. Okay, we don't know the angle, so I'm just going to put x equals, the big arc is 54 plus the small arc 32, and divide by 2. And same thing here, just like when you're taking any other average, you first have to add those numbers and get 86, and then divide by 2 and get 43 degrees. Okay, that's for this one. Those 3 were all talking about angles. The last 2 are talking about segments. Notice there's no degree marking, so that's going to be my clue. It's also not inside of an angle. It's not on an arc. It's actually on a segment. So remember, when 2 segments meet on the outside of a circle, it's always outside times whole equals outside times whole. Okay, so for number 4, there's 2 secants, okay? So the outside part is 2, the whole is 2 plus 8, and I think this is even how they asked you to do it on your quiz. And then the second one, the outside is x. Now remember, the whole is not 10 times x, it's x plus 10. Okay, so when we do this, I don't even think they asked you to solve this, but it's 2 times 10 equals x times x plus 10. I bet we didn't even ask you to solve this. All of you that like algebra, okay, remember when there's an x squared and an x, you get everything over to the same side, and then you solve from here. This one does not look like it would be factorable. This would be when you would use the quadratic formula, you'd solve. We didn't even ask you to solve this for x, we just asked you to find the right setup. So it should look something like that, okay? Next part, number 5, same thing. Remember, here we're talking about line segments again. We're not talking about angles, okay? So there's my line segment. I'm still using this formula, outside times whole equals outside times whole. Outside of that green one is 4. What's the whole thing? It's 4 plus 12, okay? Equals, what's outside of this one, x. What's the whole thing? Well, it's still x, okay? So this is 4 times 16, and of course 4 times 16 is 64, equals x squared, okay? And the square root of x is, the square root of 64 is 8. So in this case, the x value would be equal to 8, okay? Hopefully that helps. You should look back at this. This should help you review for your quiz that will be next week. And email me and sign up for a Google Meet if you still need some help.